Hello everyone. There's an interesting question here. 200 logs have been stacked in this manner. Totally 200 logs are stacked in such a way that the bottommost row has 20 logs, the next one has 19 logs, and the next 18, and it will be arranged in such a way till all the 200 logs gets finished. So now our question is, the question which we have to solve is, how many rows are made this way? In how many rows are the 200 logs placed? That's one question. And so that was the first question. How many rows are these 200 logs placed in how many rows? The second question, how many logs are placed in the topmost row? We do not know which is the topmost row, but once we find out, we should also find how many logs are placed in the topmost row. I'm just putting an arrow up for the topmost row. So I think you can just pause this video and try to find out the answer on your own. Okay, since you're back to this video now, let us try to work out on how to go about it. So the bottommost has 20 logs. Let me write it down. 20, next 19, next 18, so it's going to be 17, and this will go on till all the 200 logs are completed, are completely stacked. So can I write it this way? If I add all these 20 plus 19 plus 18 plus 17, and the sum of all these numbers, or the sum of these rows in which these many logs are stacked, the sum of all these logs should be equal to 200, because totally there are 200 logs, right? So how do we go about this? We recognize that this is an arithmetic progression. Yes, this is an arithmetic progression where the first term, or if you call the first term as A, it is equal to 20, and the common difference becomes 19 minus 20, or 18 minus 19 minus 1. It's a decreasing arithmetic progression, right? So let us find out, when will the sum, at what number will the sum become equal to 200. So we have already seen how to sum an arithmetic progression using the concept of average. We just take the first term, and then add the last term and find out the average, or divide it by 2 and multiply the number of terms. This is how we found the sum of an arithmetic progression. Or to put it in a very nice manner so that we can substitute whatever we know, we can write this as sum is equal to n by 2 into the first term A plus the last term. The last term would be A plus n minus 1d, right? So adding, it becomes 2A plus n minus 1 into d. Right? So let us substitute whatever we know. What we don't know is n. And what is that n? Once you find the n, it would become the number of rows. Right? So substituting, n is something unknown. Yeah, n is unknown. So let me have it n by 2. And of course the sum is 200. It's given that totally there are 200 logs. So it's 200 into 2 times 20, the first term, plus, once again we do not know what is n, so n minus 1 multiplied by the common difference minus 1, right? So let's now simplify whatever is here. 200 is equal to n by 2 into 40. This n minus 1 into multiplied by minus 1 becomes minus n plus 1. If you multiply n minus 1 by minus 1, it becomes minus n plus 1. So I can add this 1 to 40, or let me write it first. This becomes 40 minus n plus 1, or further simplifying, n by 2 into 41 minus n. Right? Now I can multiply both sides of the equation into 2. Right? So what do I get? 400 is equal to 41n minus n squared. Now we can recognize this as a quadratic equation in n. So it can be rewritten as, by shifting all the terms to one side, left hand side, n squared minus 41n plus 400 is equal to 0. Right? Now we'll have to solve for n. So we'll have to split the middle term in such a way that when you multiply the two coefficients, you should get plus 400. If when you multiply, you should get plus 400, and when you add, you should get minus 41. So instead of finding out the factors, let me try this method, because this being a huge number and 41 is also not a very small number. Let me try to find do the prime factorization of 400. It becomes 2 into 200 is 400, 2 into 100, 2 into 50, 2 into 25, and 5 into 5. So these are the prime factors. Now we will have to find two numbers which are factors of 400, which add up to 41. Why not we just multiply all the 2's? It gives me 2 2's 4, 4 2's 8, 8 2's are 16, and 5 into 5 is 25. Yeah, these two numbers would definitely add up to minus 41. Just that, plus 41. Just that we'll have to manipulate the signs a little. So let me rewrite this. Split the middle term and write it as n squared minus 16n minus 25n plus 400 is equal to 0, or grouping and factorizing, factoring out the common terms, it's n minus 16, and this is also second group, n minus 16 multiplied by minus 25 is equal to 0. So now we have n minus 16 and n minus 25 as the factors of this particular equation, right? Or n is either equal to 16 or equal to 25. Now let's have a look at what is n to determine which one of the numbers satisfy n. How many rows? N. Yeah. And there are 20 logs in the last row. So it becomes 19, 18, 17, 16. So the first row, even if there was a first row, that is if we had 200 logs for the first row will only contain one log, isn't it? The first row would contain just one log. So there can't be any row beyond the first row, or there can't be any row beyond 20 rows, or n can never be greater than 20. No, n has to be less than 20. So n is equal to 16 is going to be our answer for the first question. How many rows are the 200 logs stacked in? It would be n is equal to 16. Now the second question was, how many logs would be there in the 16th row? Because 16 is the topmost row, how many logs would be there? This can be easily answered by looking at what is the number of logs in the 16th row. It would be a plus 16 minus 1 into d. So this is what the 16th term would contain, or 20 plus 15 multiplied by minus 1, which is 20 minus 15, which is equal to 5. So there would be 5 logs. There would be 5 logs in the topmost row, which is the 16th row, right? So this is our answer to the puzzle. I hope you enjoyed doing this, working out this problem. Thank you.